As you can see from the title of this video, this tutorial or lesson is about mixed ionic practice. What I've done is I've listed 6 ionically bonded compounds by name, of which we will write the formulas for. And then behind it, I have 6 formulas of ionic compounds that we need to accurately write the names. The reason it's called mixed is because this is a mixture of binary ionic compounds and ternary ionic compounds, ones that would possess polyions. So, as we take a look, we're still going to go through and prove to ourselves it's ionic, because very soon we're going to have mixed in here covalent compounds, and I just want you to get in good habits. So as we take a look, all of these are names, so I need to get myself formulas. I look at potassium permanganate, and I see that potassium is right here to the left of the staircase, which is a metal, and permanganate ends in ATE, which means it's a polyatomic ion, and anytime you have a metal plus a polyion, it is ionic. With any ionic compound, the key to getting the formula is always the same. Write symbols with charges, cross them down, and then reduce. So if we take a look, potassium symbol is K. It is in group 1, so it gets a +1 charge. Permanganate ends in ATE, right? And all the ATE enders are polyions, so you have to know what they are. And permanganate is MnO4 minus 1. So we listed our symbols and charges, and then the step 2 is to cross and reduce. So those 1's come down, and I end up with KMnO4. Because 1 and 1 cannot be reduced, and we get rid of the parentheses around the MnO4 because there is a 1 outside. The second one we'll take a look at is lithium thiosulfate. And if we're taking a look at lithium thiosulfate, we'll do the same thing. Lithium is in the left side of the periodic table, so it's a metal. Thiosulfate ends in ATE, which means it's a polyion. Anytime you have a polyion, that means it's ionic, so we do symbols and charges and cross them. Lithium is Li, it's in group 1, so it gets a +1 charge. Thiosulfate is a polyatomic ion. It is S2O3 -2. So step 2, cross your charges down, and you end up with Li2 parentheses S2O3 parentheses 1. And just like I was saying in the previous problem, we don't leave subscripts of 1 or parentheses anytime that happens. So it's Li2 S2O3. Third example here, iron 2 acetate. With iron 2 acetate, we take a look. Iron to the left of the staircase. Acetate ends in ATE, which means it's a polyion. Because it's ionic, we will do symbols and charges. Iron is Fe. If we look to the periodic table, iron is in group 8. We have no rule for the charge of group 8, so there's a Roman numeral to tell us the charge on iron is +2. Acetate is a polyion. It is C2H3O2 -1. Other times you'll see this as CH3COO -1. Either way, you're looking at the same formula. It's acetate. Cross those charges down, and you'll get Fe1 parentheses C2H3O2 parentheses 2. And we don't write subscripts of 1 So iron 2 acetate will be Fe parentheses C2H3O2 parentheses 2. Jumping up to example 4. Example 4 is barium iodide. Barium is to the left of the staircase, so it's a metal. Iodide ends in IDE. Is it one of our 3 polyions that ends in IDE? And the answer is no. Right? Hydroxide, cyanide, and peroxide. So that means we're just looking at a nonmetal, which is I. So we do symbols and charges and cross, because we have a metal with a nonmetal. So barium is Ba plus 2. Iodine is I, and it's in group 17. And remember, group 17 gets a -1 charge. So we cross and reduce, and you get BaI2. Zinc chloride is the next example. Right? Zinc is Zn. It lies to the left of the staircase, so it's a metal. Chloride is not one of our 3 polyions, so we're talking about Cl. Metal with a nonmetal means that we do symbols and charges and cross it. Zinc is Zn. You'll find Zn, it's in group 12, which means we should have a Roman numeral, but we don't. The reason that we don't is because zinc is one of our 3 exceptions to the Roman numeral rule. You have to remember that zinc is always a +2. Chlorine is Cl. It's in group 17, so it is a -1. And then you cross and reduce, and you'll get ZnCl2. Last one here, I'm going to make a slight change. Right? Last one we're going to say is tin IV sulfide. Sulfide. You take a look. Tin lies to the left of the staircase, so it's a metal. Sulfide is an IDE ender, but it's not one of our polyions, so it's just talking about sulfur. Metal plus nonmetal, ionic. That means we do symbols and charges and cross them. Tin symbol is Sn. Now, there's a Roman numeral next to tin because tin is an exception the other way. Right? It is in a group that tells us it should be +4, but tin is not always a +4 charge. It can also be +2. So here, the IV is telling me that tin's charge is a +4 for when we go to cross it down. Sulfide is sulfur, S. S is in group 16. In group 16, I'll get a -2 charge. So if we cross and reduce, you will get Sn2, S4, and 2 and 4 can be reduced if we divide them by 2, and you should get SnS2. So tin IV sulfide gets the formula SnS2. So notice, all the compounds were ionic, so we did symbols and charges and crossed them for all of them. And then the polyion ones, you have to watch to make sure you put your polyion in parentheses or omit the parentheses, depending on what falls after them when you're done crossing your charges. Let's take a look at the reverse side. Here we have 6 formulas. So the first thing we want to do is figure out, is it ionic, is it covalent? And then, after we do that, go ahead and get ourselves a name. Well, if you take a look, Na2SO4, first way you know that this is ionic, right, is Na is a metal, S is a nonmetal. Metal, nonmetal is always ionic. But we also see we've got 3 elements. Anytime there's 3 or more elements, has to be a polyion, which makes it ionic. So number 1, number 2, number 5, and number 6 can all be identified as ionic because they have more than 2 elements. Right? For 3 and for 4, we have to check to see is it a non-metal or a metal non-metal. And CuO is metal non-metal, and Sr and P is metal non-metal. That's how we know that all of these compounds are ionic. And remember, when we name ionic compounds, all we do is name the metal with the root of the non-metal in an IDE, or we name the metal and the polyion just like we memorized it. Right? And then at the very end, we check, is our metal a transition? And if so, we get it a Roman numeral. So let's take a look. Na2SO4, because it has 3 elements, has to be a polyion present. I always say we should put the polyion in parentheses to help us spot it. So SO4 is your polyion. So you name your metal. Na is sodium. Name your polyion. SO4 is called sulfate. And then lastly, we check, is sodium a transition metal? It is in group 1. 1 is not the transition metal group, so there is no Roman numeral needed. Number 2, MnCO3. And again, 3 elements here. Right? So the 2 nonmetals must be a polyion. So I name my metal, Mn is right here, it's manganese. And be careful between manganese and magnesium. Manganese is Mn. CO3 is the polyion carbonate. And we leave carbonate as is. And then lastly, is manganese a transition metal? Yes, it is. Is it one of our 3 exceptions? Cadmium, zinc, and silver? It is not. So we have to figure out the Roman numeral. The first thing I try to do is uncross my charges. So if I do that, it puts a 1 here and a 1 here. So then you'll have to say, is -1 the correct charge for carbonate? And the answer is no. Carbonate's supposed to be -2. So uncrossing won't work. Right? Whenever that happens, we have to do a little bit of extra work. We have to create that table. So if we take MnCO3 and then we break it in half, there is 1 CO3, and a CO3's charge is -2, so the charge from the right is -2. The left has to be equal and opposite, and we get that by the number of magnesiums, which is 1, times its charge. So 1 times X has to be +2. Well, X must be equal to +2, so manganese's charge will be represented by an I. Moving on to CuO. Right? We said this was ionic because it's a metal plus a nonmetal. So we name our metal. Cu is copper. O is not a polyion, so we're talking about oxygen. So we write the root of the nonmetal with an IDE, which makes this sound like oxide. Then we check, is copper a transition metal? It's in group 11, so yes. Is it one of our exceptions, A, G, C, D, or Zn? No. So we need a Roman numeral. First thing we do is try uncrossing, which would put a 1 on top of each. And then we say, is O supposed to be a 1? And the answer is no. O is supposed to be a 2, so uncrossing is not going to work. So that means we'll have to make a table. So CuO, break it in half. I have 1 oxygen, and oxygen is supposed to be -2, which means the charge here is -2. This must be a +2, and there's 1 Cu, and again, just like above, X ends up being +2, so we get copper II oxide. Moving over to example 4, Sr3P we said was ionic because it's a metal with a nonmetal. So we name our metal. Sr is strontium. P is a non-metal, right? So we have to make sure it ends in IDE. So strontium phosphide. And then we say, is strontium a transition metal? Strontium is in group 2, so the answer is no. So strontium phosphide is good just the way it's written. Moving on, K2SO3. 3 elements here, which means there's a polyion present. That's what told me it was ionic. Remember, the polyion is always the non-metal part. So we name our metal, and then we name our polyion. K is potassium. SO3, the polyion, gets the name sulfite with an I. And then we have to check, is potassium a transition metal? K is in group 1, so the answer is no, which means we don't need a Roman numeral. Last but not least, Ba parentheses C2H3O2 parentheses 2. I see 4 elements, and there's already parentheses around my polyion, right? So that means it's obviously ionic. So I name my metal, which is Ba, and that's barium. I name my polyion, and C2H3O2 is called acetate. And then I check, is barium a transition metal? Barium is in group 2, so the answer is no. So we don't need a Roman numeral. So a little overview there on ionic compounds. I hope this cleared up any issues you may have been having as you were trying to go through some practice problems and worksheets and whatnot. As always, if you're having any trouble, feel free to come in and we can do some extra work and get you sorted out.